Hey everyone, welcome back to my math tutoring videos. Today we're doing the quotient rule, and you use this for a function divided by another function. And unlike what most people would expect, it's not just a matter of taking the derivative of the numerator and the denominator and then just finding the quotient. It's a little bit more complicated than that, and as daunting as the rule looks, it's important. So I would suggest that you actually try and understand the rule properly. And so I did the proof for this beforehand as well, but I'll go through the proof again like I did with the product rule. If you don't feel like watching this, if you don't find it interesting or useful for any reason, please skip ahead. And if you do, please you can feel free to stay. And so what I did with this is like with any other derivative, I used the limit definition. And so that means I divided f of x plus h by g of x plus h. And then in the next step, I got a common denominator by kind of cross multiplying. So I get g of x plus h and g of x in the same denominator, and I took the 1 over h out for now. And we'll get to that a little later. So my numerator looks a bit like this. And I apologize for the lack of neatness in this line at least. So now the next step is I subtract and add f of x multiplied by g of x, and this is so that I can actually get a limit definition type of thing. And I did the same thing with the product rule too. So I subtracted f of x times g of x so that I could take the common factor of g of x out, and then I get a proper limit definition. And it's the same thing here, except I take f of x out and I get a proper, I take negative f of x out and I get a proper limit definition. So that means I have, and you may have noticed from this step to this one, I actually switched the h and the g of x plus h times g of x. And I put this outside because I put this outside because we would use it later. And I kept this inside so that it would kind of go away once I actually use the limit definition of a derivative. And so now we actually got to this point where we take the derivative of the numerator and multiply it by the denominator and subtract the derivative of the denominator multiplied by the numerator. So we get something that looks like this line over here. And as this line approaches 0, you get your actual quotient rule. And this looks a little daunting to read, but how I and most of my friends actually do think of it is they think of the original function as high over low. So for the derivative, they say low d high, and d just means derivative, minus high d low, all over low squared. And I think this just might be an easier way of remembering the actual quotient rule. And you may have noticed that with the product rule, and I may have pointed this out, it's commutative, meaning that the order doesn't matter. However, with the quotient rule, that's not the case, because there's a subtraction sign over here instead of an addition sign. And with the quotient rule, we can actually prove 4 more derivatives, all of them trig. So the first derivative that we'll actually prove is tangent x. So f of x is equal to tangent x. And tangent is just defined as sine over cosine. So now that you have this, will you be able to find the derivative? Pause and see if you can do it. Okay, let's begin. So in this case, our high function is sine and our low function is cosine. So the quotient rule is low d high, so cosine x multiplied by the derivative of sine x minus sine x multiplied by the derivative of cosine x all over cosine x squared. And I'll just keep this f prime of x so that you know what I'm referring to. So that means cosine x multiplied by cosine x minus sine x multiplied by negative sine x all over cosine x squared is equal to our new derivative. And this negative and negative, that just becomes a positive. Cosine x times cosine x just becomes cosine squared x, and sine x times sine x becomes sine squared x. This identity looks pretty familiar. What's the value of this? It's just 1. Cosine squared x plus sine squared x is a Pythagorean identity that just becomes 1. So your derivative so far is 1 over cosine squared x. So that means 1 over cosine is secant. So that means the actual derivative is secant squared x. So the derivative of tangent x is equal to secant squared x. And using that, why don't you try and find the derivatives of secant x, cosecant x, and cotangent x. And to give you a clue, I'll tell you what secant x is in terms of a reciprocal. So you have secant x is 1 over cosine x. And for the purpose of this video, I'll also give you the cosecant and cotangent reciprocals. So that means cosecant is 1 over sine x, and cotangent is 1 over tangent x, or cosine x over sine x. So now pause the video and see if you can try and find the derivative. Okay, let's begin with secant x. So now we have 1 over cosine x. So that means we take 1 is our high and cosine x is our low. So low d high means cosine x multiplied by the derivative of our high, which is just 1, minus 1 times the derivative of cosine x. So d over dx cosine x all over cosine x squared. So the derivative of any constant is just 0. So this becomes 0, and by extension, this also becomes 0. And the derivative of cosine x is negative sine x. And so I'll just write that over here. This negative and negative cancel out, so that becomes positive sine x. So you have sine x on the numerator and cosine squared x on the denominator. So now it's just a matter of splitting this into some other fractions. So you have sine x over cosine x multiplied by 1 over cosine x. Sine x over cosine x, as we learned when we were figuring out tangent, is just tangent x, and 1 over cosine x, as we figured out up here, is secant x. So the derivative of secant x is secant x tangent x. So now cosecant, it's the same logic where 1 is the high and sine is the low. I don't know why I wrote cosecant. So that means f prime is equal to 0 times sine x. I'm just using the same logic from last time and kind of trying to speed run it. Minus 1 times the derivative of sine x all over sine x squared. So that means the derivative of sine x is just cosine x. The derivative of 1 is just 0. So you get negative 1 times cosine x. So that's negative cosine x. And like we did with secant, we'll just split that into an actual fraction. So we have negative cosine x over sine x times 1 over sine x. And up here, I wrote the identities that we might need to actually simplify this. So that means this derivative is equal to negative cotangent x times cosecant x. And now for the last one. So cotangent is just cosine x over sine x. And where cosine x is our high and sine x is our low. So the derivative for this is low d high minus high d low all over low squared. So that means we have sine x times the derivative of cosine x minus cosine x times the derivative of sine x all over sine x squared. So this means we have negative sine x times sine x minus cosine x times cosine x all over sine x squared. And from the numerator, we can take out the common factor of negative 1. And so we'll just put that aside. Sine x times sine x becomes sine squared x. And cosine x times cosine x becomes cosine squared x. And this negative is outside the fraction, so it distributes to every term, which is why I have a plus over here. And this looks familiar. In fact, we dealt with this in the tangent derivative. And it's also a pretty popular Pythagorean identity that just equals 1. So that means f prime of x is equal to negative 1 over sine squared x. So that means it's negative cosecant squared x. So bottom line for this video is the quotient rule is the denominator. Say you have, okay, I'm gonna restart that. Say you have a function which is high over low, where high and low are two different functions. That means your derivative of that function is low times the derivative of high minus high times the derivative of low all over low squared. So say it's u over v, where u and v are both functions. That would mean it's u prime multiplied by v minus u multiplied by v prime all over v squared. V in this case is low, u is high. And then we also figured out a couple of derivatives for a few trig functions that we didn't do before. And that is tangent. So the derivative of tangent x is secant squared x. The derivative of secant x is secant x times tangent x. The derivative of cosecant x is equal to negative cosecant x cotangent x, and the derivative of cotangent x is equal to negative cosecant squared x. Thank you for watching this video, and please stay tuned for the next one and just keep practicing math.